this lesson, we're going to look at how we can use our calculator to find our trigonometric functions. We know that for certain degrees, 30, 60, 45, for our quadrant angles, 0, 90, 180, and 270, that we always give exact answers for. But for all of our other angles, we need some decimal approximations. So we're going to look at how we can use our calculator to find these. Now, by definition, we know that 1 degree, which we use a degree symbol for, is equal to 1/360th of a revolution. So that's why we will say that there's 360 degrees in a revolution. Now, sometimes we want to break these degrees down into smaller units, and so we have what we call minutes. We have 1 minute. And for a minute, we use the same symbol that you use for feet. 1 minute is equal to 1/60th of a degree. So that means there's 60 minutes in 1 degree. And then we break our minutes down into seconds, and we use our inch mark for that. And that's equal to 1/60th of a minute. So that means that there's 60 seconds in 1 minute. So we'll be breaking our degrees down into these units. Now, for most of our problems right now, we'll just use degrees and minutes, but I will show you how you can work with seconds on your calculator. So we're going to look at a couple of problems where we do these first of all by paper and pencil or on our own, and then we'll look at how to do them on the calculator. But I do want you to understand how you would go about adding and subtracting your degrees and minutes. So let's take the problem 48 degrees, 49 minutes, and we're going to add to that 72 degrees and 26 minutes. Now, back in algebra, we talked that you can only add like terms. You can only add, feet to feet. You can only add x's to x's. You have to have like terms to be able to add or subtract. Well, the same thing is true here. We can only add minutes to minutes and degrees to degrees. So as we go through this, we'll add up our minutes. So we have 75 minutes. And we'll add up our degrees, and we have 120 degrees. We can't add the degrees to the minutes. We have to keep those separate. But when we did this, we ended up with more minutes than 60. And we know that 60 minutes is equal to 1 degree. So we're going to have to simplify this. So what we're going to do is we're going to subtract those 60 minutes, which leaves us with 15 minutes. Now those 60 minutes we're going to change to degrees, and so we'll add that 1 degree then to our degrees, and that gives us a total of 121 degrees and 15 minutes. You never leave your minutes with more than 60 because that can be changed to a degree. If we want to subtract, let's say we have 90 degrees and we want to subtract 24 degrees, 14 minutes. Well, we can only subtract minutes from minutes. We don't have any minutes, so we're going to have to do what you would call borrowing. It's actually renaming. We're going to rename this 90 degrees as 89 degrees. And that 1 degree that was left, we will rename to 60 minutes. Now we can subtract, because you subtract minutes from minutes. So we can subtract here, and we'll get 46 minutes. And when we subtract this, we get 65 degrees. So in our subtracting, we get 65 degrees, 46 minutes. So if you didn't have enough minutes to subtract from, then you would rename. The same thing's true if we had 75 degrees, 14 minutes, and we wanted to subtract 20 degrees, 35 minutes. Well, we can't subtract 35 from 14. We didn't have enough minutes there to subtract. So again, we're going to have to rename. We're going to rename our degrees. We're going to take one of those degrees, so we'll have 74 degrees left. That one that we renamed is now 60 minutes. Well, we already had 14 minutes, so that gives us a total of 74 minutes. Then we can subtract from that. So in subtracting, we would get 9, and 6 minus 3 is 3. So we would have 54 degrees, 39 minutes. So if you don't have enough minutes, then you have to, what you've always called borrowing or renaming. So we're going to take one of those degrees and we're going to rename it into minutes, add it to those minutes that we already had. So we want to learn to deal with this. We also know that we're going to work with what we call decimal degrees and degrees in minutes. And so if you're working with this, then let's say that we have something written 27 degrees, 15 minutes. Well, that's in degrees and minutes. If we need this as decimal degrees, which we will for most of our problems, and your calculator will change it, but so that you understand how it's changed, that 15 minutes is 15 sixtieths of a degree. And if you divide 15 by 60, then you're going to get 25 hundredths. So 25 degrees 15 minutes is the same as 27 and 25 hundredths of a degree. This is what we would call decimal degrees. And so if you're having to change your degrees in minutes, this is how you would do it. Now, if you had it decimal degrees and you were wanting to change it back to 25 degrees in minutes, well, the way that you would do that is you could set up a ratio, 25 100ths. 25 hundredths is the same as what over 60? And then you can do your cross product, and you'll get the 15 degrees. If you do your 25 times 60 and then divide it by 100, you'll get your 25 hundredths. Basically, what it turns out to be is you'll multiply the 25 hundredths, another easier way, multiply your 25 hundredths times 60, and you'll get your 15 degrees. And that I actually wrote that incorrectly. It's not that this is 25 hundredths. It's that equals 15. So that's how you would change it back to get it to be in degrees and minutes. Now let's look at our calculator of how we would go through and do our addition and subtraction on the calculator and how we change from degrees and minutes. So we're going to do some problems very similar to this. Let's pull up our calculator. And we can't quite see those problems. So let me write them up here again, just over to the side. What we had was our 40, we had 48 degrees, 49 minutes, plus 72 degrees, 26 minutes. We added those. Another problem that we did was 90 degrees minus 24 degrees, 14 minutes. And so we did that problem, which is what we actually have worked out down here. So let's just do it with our calculator and see if we get that same answer. Now, as you work with this on your calculator, there's actually a degree mode and a radian mode. If you're using the symbols, it really doesn't matter which mode you're in, but it's often wise to go ahead and change your calculator to the degree mode if you're going to be working in degrees. Because a lot of times we don't end up putting that degree sign, and so we want it to be understood. So we went to mode, and we're going to change this over to degrees. Now let's work our problem. We've got 48, and we need to show that that's degrees. So we go to second, and then our apps button, which you can see right above it, is angle. And our number 1 here is our degree symbol. So we'll press degrees. Then we'll do our 49 minutes. Again, we go to second, angle. And number 2 is our minute button. So we'll press 2 plus 72 degrees, which was number 1, and 26 minutes. Whoops, wrong one. And then we press enter. Now notice our calculator puts it in decimal degrees. But normally if you're working with degrees in minutes, you want your answer in degrees in minutes. So what we do to change it, we go to second angle. If you'll notice, number 4 has an arrow in degrees, minutes, and seconds. So this is saying we're changing this to degrees, minutes, and seconds. So we'll press 4, then we have to press enter, and it changes it back to degrees, minutes, and seconds. Let's take our second problem, 90 degrees. Minus 24 degrees, 14 minutes. Enter. And again, we got it in degrees, decimal degrees. We're going to want this in degrees, minutes, and seconds. So we'll do second apps number 4, press enter, and it changes it back to degrees and minutes. Now, you also have an option, and I can't show it done with these, but a lot of your little scientific calculators are a little bit more user-friendly because you don't have to go to so many of your menus. And they'll actually have a button on the keyboard that's for degrees, minutes, and seconds and changing. So you may want to look into getting one of those. Let me show you where you would find your second button if you needed it, because we're talking about degrees, minutes, and seconds, and it might be that you're needing a problem in degrees, minutes, and seconds, and so you need to be able to find your second button on the calculator. So let's say that we wanted to enter 41 degrees, 25 minutes, 31 seconds. And let's just go ahead and add that to something. So 21 degrees, 15 minutes, 17 seconds. So let's add this problem. So we have 41 degrees, 25 minutes. Now, while that's up there, notice I see a minute, but I don't see anything for seconds. And there's even an arrow that says we can go down. So let's just see if there's something later. We know that we're actually making this. Okay. Okay, it doesn't have anything there for seconds. So right now we need minutes. So we've got our minutes, but we're going to put in our 31. We need seconds. Okay, there wasn't a button in with our angle. So what we actually see is over here with our plus key, right above it in green is our seconds. It's our quotes. And so that's the one that we're going to use. Now since it's in green, we'll press our alpha button and then we have our seconds. Then plus 21 degrees, 15 minutes, and then 17 seconds. So we go to alpha and then our plus key and press enter, and it added it all, and it just happened that when I added those that became 60, and so to get it back to degrees and minutes we do second angle number 4, enter, and so it changed it back to 62 degrees. Well, it actually is 62 degrees. Yeah, that's not 60, that's 48. 62 degrees, 40 minutes, and 48 seconds. And so it changed back to degrees, minutes, and seconds. So that's where you find your second key. So you're going to have some problems where you are to add and or subtract with degrees, minutes, and seconds. And then on some you'll need to round your answer. Probably they'll tell you what to round it to, and on some you'll change it back to degrees, minutes, and seconds. But this is how you would use your calculator to do that. Now, we also need to be able to find our functions with our degrees, minutes, and with our calculator. And so let's say we want to find, say we want the cosine of 37.8 degrees. So 37 and 8/10 degrees. And let's also look at the tangent of 58 degrees, 45 minutes. And let's look at how to find those using our calculator. Well, it's real simple. We've got our cosine button, and we have 37.8. Now, since we put our calculator in the degree mode, we don't have to put a degree symbol up there. And so we can just press enter, and it will give us the cosine of 37.8 degrees. It would not be wrong if you put a degree sign, 37.8. We could put our degree sign, and it would give us the same answer. Now, if our calculator were in the radian mode, then you would have to put your degree symbol here if you were wanting to work in degrees. So you need to know what mode your calculator is in. Okay, and if we wanted the tangent, now here, since it's in degrees and minutes, we have to put our symbols. So 58 degrees, 45 minutes. And we get 1, and we get some big long number. Now most of the time we don't want that many decimal places, so most of the time we'll round to 4 decimal places is the usual number. So if we were doing this one, we have 1.1234. The 9 is in our 4th decimal place. We look at the next digit, which is a 4. So it's going, this would stay 1.6479. Now we didn't do that up there with our cosine, so let's go back and look at it it was 0.7901. The 1's in the fourth place, the next number's a 5. So we would round that up to 7902. So you need to be aware that you will have to do some rounding. Okay, let's look at just an idea of, let's say we want to find the sine squared of 14 degrees. Okay, we talked earlier in an earlier lesson that when you've got the square there, this means the sine of 14 degrees squared, where you're finding the sine of the angle first, then squaring it. Well, as you work with your calculator, you have to tell your calculator what to do. So if we're going to do this problem, then what we need to put is our parentheses, the sine of 14, close the parentheses, and since I opened it with parentheses, I need to close that, and then I could put square. Now, it wasn't necessary that I put those parentheses to begin with. I can put the sine of 14, but it is necessary that I close my angle before I hit the square key. And there I get the same answer. Let me just show you if we put sine 14 and I hit square before I closed, and well, let's just say I didn't close them. Then if you'll notice, I don't get the same answer. So when you were squaring the function, we remember that we have to close our angle. That gets the sine of the function, and then we're going to square it. And so you've got to be sure on your calculator that you enter things correctly so that it understands what you're doing. Okay, we want to look at our reciprocal functions. If you notice, your calculator does not have a secant, cosecant, or cotangent button. So we want to see how we're going to have to enter these on our calculator. If we want the secant of 56 degrees, okay, let's think what this means. This means 1 over the cosine of 56. So we have to think we have to think of this in terms of its reciprocal function. Okay, we have two ways of entering this on the calculator. One is to put 1 over the cosine of 56. The other is to put the cosine of 56. Your calculator will put that 56 in parentheses. Then we're wanting the reciprocal of that. And so we will hit our reciprocal button. But you have to do things in the correct order. So let's look at this both ways. Say we want 1 divided by the cosine of 56 degrees. So we get 1.7883. If we round that to the nearest decimal place, 1.7883. Okay, or we can do the cosine of 56, close our parentheses, and then we have our reciprocal button. And so we're saying we want the reciprocal of the cosine, and you notice we get the same answer. So anytime you're trying to do a reciprocal function, then you're going to have to use a reciprocal. Let's say we want the cosecant of 13 and 49 hundredths degrees. Again, it's helpful to you to think of the reciprocal. This is equal to 1 over the sine of 13 and 49 hundredths degrees. So that's how we would enter it on our calculator. We can do the sine of 13.49, close our parentheses because it's the function that we're wanting the reciprocal of. Later on, there's things that we'll want the reciprocal of angles. Well, we never take the reciprocal of an angle, but we're going to be working with our reciprocals in a different way. You have to know when to hit the reciprocal button. So we want this to get the function, then take the reciprocal. And if you're ever in doubt, then write it, put it in exactly this way, 1 over and 1 divided by, another way of writing the reciprocal. So you need to be able to find your reciprocal functions, and we do that using those. Now, we're going to go through and we're going to make us a table, and we're going to find some things on our calculator. And so it will help us then as we go through and we look at a few things. These are not necessarily ones that we're going to want to do using our calculator because they're going to be some exact values. But they are ones then that we can easily see how our reciprocals work. Okay, what I've done here is I've put some of the special angles that we know exact values for. We're going to also work with the decimals in this case. Most of the time you will not use your calculator to find the cosine of 30 degrees or the cosine of 45 degrees. But we're going to do it at this point just to show the reciprocal. But let's just go through. We know that the cosine of 0 is 1. We know that the cosine of 30 is square root of 3 over 2. We know the cosine of 45 is the square root of 2 over 2. The cosine of 60 is 1/2. And we know that the cosine of 90 is 0. We already know that, but we're going to put our decimals in here, in this case, just so that we can see how to use the calculator. So let's pull up our calculator again, and we want the cosine of 0, and it gives us 1. So we have that. We want okay, now we could go through and enter each one on the calculator, but let's look at how we could set up a table and actually go through and have it do all of this at one time. We haven't spent a lot of time doing that. But let's go to a table and we're going to do stat, and we're going to do number 1, edit. Notice it sets us up a table here. In this first column, we're wanting to enter these values. So we'll enter 0, enter 30. And this is going to get us all of our answers at once where we won't have to go through so much. 45, 60, and 90. Now we're going to arrow over to the second column. What we're wanting to do here is to put something up at the top. So we're going to arrow up to L2. And what we're wanting up here at the top is cosine. Now, we don't want just cosine x. What we want is the cosine of these values. And so that's L2. The way you find L2, it's right above 1. So we do second, and then your number 1, and that puts L2. Close your parentheses and press enter. Notice it went through and it entered all the values. The cosine of 0 is 1. Cosine of 30, if we did square root of 3 over 2, you would get 0.8660. The cosine of 45, cosine of 60 is 1/2. So now we want to go to our third column. We want to go up to the top, and we want that to be the reciprocal. So we're going to say it's the cosine of L1. Oh, or we could put just the reciprocal of L2. We could do that. Let's just look at that in a minute. But let's go back and put the cosine of L1, then reciprocal, and press enter. Whoops, I had a mistake there. I didn't put L1, I just put 1. So second L1. Now I can press enter. Maybe not. cosine of L1 reciprocal. Okay, let me just start over. I want the cosine of L1, close my parentheses, and then I want my reciprocal. Okay. Okay, if you notice what we keep getting here as we're trying to put in our function, even if we put in second L2 and then reciprocal and we press enter, we keep getting an error message. And it's saying the error is dividing by 0. Well, if we go back to our table, if you notice down here, for 90 degrees, the cosine was 0. That's what's giving us problems. So let's just go back and let's clear that off. And let's go back over here to column 1 and clear out the 90. We're going to delete it. We'll go over to column 2 and we'll delete that 0. And now let's go to column 3 and put in our, we can put in cosine, second L1, close the parentheses, reciprocal, and press enter. And it gives us the reciprocal of all of these values. And the problem with trying to do it in that way is it wasn't going to let us divide by 90, or by 0, which means that the secant of 90 was undefined. And so you can set it up and find your values. And that was a way of showing you how to make a table to go through and to generate all of these values. Okay, let's look at just a little bit more then at our what we would call our inverse functions. And for our inverse functions, this is where we're given the function and we're trying to find the angle. So the idea behind this is if we were wanting to know that the sine of what angle equaled 1/2, or we'll just use the decimal, 5/10. We wanted to know, well, what angle equaled that? Well, we know the sine of 30 degrees equals 1/2, so we know that our angle is 30 degrees. And I wanted to start with one that we did actually know. The way that we find this, or the way that we would write this, is it's called the inverse sine. And our inverse sine, our symbols for that, is we use the inverse of the function. Now remember, sine without an angle has no meaning. So this is saying we're wanting the inverse of the function. We use that same symbol back with our functions when we had f of x. Back in algebra, we had f of x, and then we had f inverse x. And remember, that didn't mean reciprocal, it meant the inverse of the function. So we're wanting the inverse of 5/10, and that will then give us our angle. The way that we do this on our calculator is we'll go back and let's quit this table. So you'll notice above the keys, we have our inverse function. So we would do second sine, and we would do 0.5. Press enter and it gives us 30. So that would be 30 degrees. If we wanted, say we want the cosine of what angle equaled 0.9770. This is one we don't know. So what we're actually asking is the inverse cosine of 0.9770 equals what angle? So we're looking for the angle. Well, we go to our calculator and we would do second cosine 0.9770, enter, and it gives us that it's 12 degrees and then we've got this long decimal. Well, we can round our decimal off to 4 places, so we could have 12.3123, or we can then change that to degrees, minutes, and seconds. So we go to number 4, and that would change it. 12 degrees, 18 minutes, and 44 seconds if we rounded it off to the nearest second. So we can get our value for that. Let's look at just a few more. Okay, let's go through and look at several problems that I've got up here, and we'll do them on the calculator. So the first one, we want the angle whose sine is 0.4926. So that means we want the second sine, or the inverse sine, 0.4926. And so that would be 29. And if we rounded this off to the nearest hundredth, 29 and 51 hundredths degrees, or we can change it to degrees, minutes, and seconds, depending on what your instructions are. 29 degrees, 30 minutes, 42 seconds. Or if we rounded it to the nearest minute, 29 degrees, 31 minutes. So you just look at what you want to round it to. Okay, if we do the next one, we want inverse cosine 0.1785. So 79.72 degrees, or let's round this one to the nearest minute, would be 79 degrees, 43 minutes. And if we did the tangent, then inverse tangent 2.314. So we have 66.63 degrees, or if we need it in degrees, minutes, and seconds. To the nearest minute, 66 degrees, 38 minutes. To the nearest second, 66 degrees, 37 minutes, 42 seconds. To the nearest minute, to the nearest degree would be 66 degrees. So you have to look at what you're told to round to know how to do that. Now we get to an inverse function. And so we've got to go through and think how we would enter this on the calculator. So the cosecant is the reciprocal of the sine. So let's think of how we would go about doing this. If we took the reciprocal of both sides here, the reciprocal of cosecant is sine. The reciprocal of this would be 1 over this. But sine is the reciprocal of cosecant, and so we've got our reciprocal here. So what we're going to do is we're going to want the inverse sine. Then we're going to put in parentheses, we want the reciprocal of this. So you can put 1 divided by 2.6134 or 2.6134, and then you want the reciprocal of that. And I'll put it in both ways so that you can see that it works either way. But you have to think, I want the reciprocal of cosecant, which is sine, so you're going to do inverse sine, and then you want the reciprocal of the function. You'll always take a reciprocal of a function. You'll never take the reciprocal of an angle. So as we put this in, we want second sine. Then to enter it the way I've got it written here, 2.6134 We want the reciprocal of that, and we put it before we close the parentheses because we're wanting it to get that reciprocal and then do the function. So 22 degrees, 22.50 degrees, if we rounded it to the nearest hundredth. I also said you could do this second sign. If you were in doubt, then you could do 1 divided by 2.6134. You get the same answer. Now, up here I said you had to put that reciprocal inside the parentheses. Let's just see what happens if you don't. If we do second sign and we do 2.6134 and we closed it and then put our reciprocal button, it's going to give us an error message, and it deals with the domain. The reason for that is, remember, our signs are always between -1 and +1. Sine is opposite over hypotenuse, which means that it always has to be less than 1, or at 90 it's equal to 1, but it can't be bigger than 1 because the opposite side can't be bigger than the hypotenuse. So that's why it gives us an error message here. And so we could go back and delete that parentheses and then put our reciprocal inside, and it will give us that value. So for the cotangent, okay, cotangent is the reciprocal of the tangent. So we're going to do inverse tangent, and then we're going to need the reciprocal of this number. So 1.8132. We want the reciprocal and then close our parentheses. So that would be 28 degrees, 28.88 degrees. For the secant cosine. So we're wanting inverse cosine, and then we're going to need the reciprocal, 4.3859, and we want the reciprocal of that. Close the parentheses, and we have 76.82 degrees, or let's change this to the nearest minute. So 76 degrees, 49 minutes. And we can have our value. Now, we can do lots of computations with these, and we can see certain things. So let's look at a few more problems. Let's look at a few problems that deal with concepts that we already know. Here we're looking at the sine of 56.7. So 56.7. We get that the sine's 0.8358. The cosine of 33.3. Is 0.8358. We ended up with the exact same answer. Well, if you start looking, sine and cosine are cofunctions, and 56.7 and 33.3 are complementary angles. If we add 33.3 and 56.7, we get 90. So here we have cofunctions of complementary angles are equal. We can also use the calculator to verify some of our identities. Here we have the cosine squared of 85 plus sine squared 85. Well, we know we have an identity, cosine squared theta plus sine squared theta equals 1. Well, let's just verify this with our calculator. Now, for cosine 85 squared, remember what we have to do is do cosine of 85, then close our parentheses and square it so that it gets that function first, plus sine of 85 squared, and then when we press enter it should give us 1. And so again, we could use our calculator to verify some of our trig functions. Now what you need to do is practice with your calculator of entering your decimals and your degrees, finding your inverse functions, changing from degrees, minutes, and seconds to decimal degrees, and decimal degrees to degrees, minutes, and seconds, and become very familiar with how to use your calculator.